the square root of 2i cubed then. Let's have a look at this. Let's simplify it first using properties of indices. So it's the square root of 2 times I cubed square rooted also. And that's to the 3 over 2, isn't it? So it's the square root of 2 times I to the 3 over 2, because that's power half. So it's 3 to the power half. Power u times, that's where you get 3 halves, which is 3 over 2. Which we can write as root 2 times I to the half. So here we need just to work out I to the half. So I to the half then, let's just work that out as a subproblem. So I'll draw a line across the page just to remind us that we're doing a subproblem. Squaring both sides, so I will equal a squared minus b squared plus 2abi. So that tells us then that a squared minus b squared equals 0. A squared equals b squared then. And it also tells us that 2ab is 1, so and ab equals a half. So b is equal to 1 over 2a. Substitution then. Let's turn our attention to this to work out substitution. So a squared equals b squared, which is 1 over 2a squared. Which is 1 over 2a squared, which is 2a times 2a, which is 4a squared. Move the a squared up. A to the 4 equals 1/4. And then take quarter root, the fourth root. So a on the left will equal the fourth root of 1/4. So you can write it like this, if you wish, which is just divide it up. The quarter of the 1 is 1, and the fourth root of 4 is root 2. And it's a plus and a minus, isn't it? 1 over root 2, i.e. a will equal, and we can just rationalize the denominator, root 2 over 2, plus or minus. There's a. Okay, so, right, we've got that then. So root 2 over 2, there's a. And we know that b is equal to 1 over 2a from before. So here, a plus bi equals. So if it's root 2 over 2 then, is a. The b will be 1 over plus 1 over. This can also be 1 over root 2. Yeah? If you think about it in your mind's eye. And then if you put that in for a, 1 over root 2 here, it'll just cancel. The root 2, the 2 will cancel, leaving a root 2 here, so you get another root 2 over 2. When you work it out, and that's b. And then the other value, minus root 2 over 2, will simply give a minus root 2 over 2 here. I. That's the end of the subproblem. So let's just square that and see if we get the answer we wanted. So if I square this, I get a half. If I square this, I get minus a half. So they'll cancel. And then if I times them together, I get 2 over 4, I get a half, plus another half, is 1 lot of I in the middle, 2 terms. So that looks good. So now we go back to our original problem, and we see that I to the half was the problem here. So we got root 2 times I. So root 2 times I. So answer equals root 2 times I times one of these. So it will be this one, root 2 over 2 plus root 2 over 2i, bracket, or it will be root 2 times I of this one underneath, minus root 2 over 2, minus root 2 over 2i. So let's try and work that out. What are we going to get? 2 over 2 is 1, we get I, and we get 1 plus I here, and this looks like it's going to be minus 1 minus I. So if we square these, let's square this one for example, we get 1 minus 1 is 0, plus 2i 2i. And we want 2i cubed. So what have we got here then? Oh, we've got an I squared, sorry. See it? So we got root 2i, yeah, and I squared is minus 1. So that'd be a minus, won't it? And this would be a plus, because we've got an I squared. That I should be there, of course. So just correcting, because we've worked out the answer was wrong. Now let's square this. This squared is 1, this squared is minus 1, so they'll cancel each other. And the middle terms will give minus I and another minus I, which is minus 2i. And then the minus 1 will be, of course, the I squared. So that looks fine now. Good.